Hi and welcome to my new video. This time I will talk about crypto shredding, which can be a pattern or a solution to implement the right to be forgotten of GDPR legislation. So I will not demonstrate the architecture because I already proposed it in the article which is linked in the description of this video, but rather than that I will show you how to encrypt some data with some key and read it in 3 different languages, namely in Java, in Python, and in SQL on top of PostgreSQL. So I will start just to show you, I have some Docker Compose key, which is very straightforward, and I will start it right now. And in addition to this Docker Compose, I also have some Java class which will encrypt and decrypt a birthday of a user with a key which is dedicated to this user, so this key is not shared. And we suppose that this key is stored in some encryption store, and that whenever we need to read this sensitive data, we will fetch this key and decrypt the data, maybe to do some data exposition or machine learning training or whatever. And I have also the same for Python and for SQL, but it's not in the script. So for the SQL, I will access the Docker image, and I'm connected to the database. And now I will show you quickly the code for Python, which is very straightforward, which is in fact the same code, the code that you will find elsewhere on the internet. I'm using the Cypher class from crypto package, and I'm also doing some padding and unpadding because to use this encryption, we will need to have the string which is the multiple of 16 bytes, and to show you that I can simply tweak a bit this pad operation, maybe just that, and I will simply return the input, and you will see that it will fail with the message saying that input string must be a multiple of 16 in length. So that's the reason why during the encryption we have to add some extra bytes to fit to these 16 characters, or to this multiple of 16 characters. And as you can see at reading, we remove these extra bytes with this unpad method. That was for Python. For Java, it's kind of similar because we are initializing a class for the encryption key. We're retrieving the instance of the encryption or decryption algorithm. We are initializing the mode, so encrypt or decrypt, regarding on whatever you want to do, regarding what you want to do. And later we are either encrypting this or decrypting, and we return a string encoded on base 64. And regarding SQL, I'm using here the decrypt and encrypt methods, which are followed by encode or decode, and decode which will translate the base 64 string to an array of bytes, and encode which will do the opposite, so we'll take the array of bytes and convert it to string. And finally, I'm also using convert from method that will take the array of bytes decrypted, the array of bytes which represents the decrypted value, and convert it to more readable format in string. So let me first run this in SQL and show you what is the generated value. So sorry. So yes, I did the opposite. I used the encrypted base 64 and I retrieved the birthday with the user key. What if we change the user key? As you can see, we cannot decrypt it. We will have, now I will check if we will have the same encrypted value in the Java code. And as you can see, yes, we got exactly the same base 64. And what about Python? You can see that's also the case, and all this by using a very standard libraries, which are either extra libraries in Python, which is PyCrypto, or the native libraries under Java's crypto package in Java, which you can of course use in other JVM compatible languages like Scala or Groovy. And what about the encryption, sorry. So if we do that in SQL, you can see that we still have the same base 64 code that we can retrieve or decode later correctly. So this demo is there just to show you the code, but if you want to discover the architecture and also some drawbacks but also the advantages of this approach, I invite you to the article which is linked in the description of this video. It was Bartosz Konieczny from waitingforcode.com. Thanks for watching.